Yes, sir, not same.
Okay. So here now it is here.
Yes, sir.
Okay. So here, what are we doing? We have taken the one, we are implementing one simple function, repeat x. So we'll take the one value, and that value will be repeated n times. Okay. So that's why this is we have taken as a input x comma n, and this is the function definition, and this is the also the function. So this particular module has only single function. So I save the function save as I have already saved this. So module 1. So my module name is module 1. Okay, and obviously this will be saved with .py extension, just like previous one, .py extension. Now what we will do, here we have this module 1 module has only one function in its body. Okay, so now we can directly import the function from here, command prompt. What will be the syntax? Im import module 1. So if I want to access the module 1, I want to calculate. So module 1 dot, you see, if you have successfully imported the module, then automatically the related function will be available. Everything will be available in this. After putting the dot on the module, you will get the related function which are available in the module. Okay, so here our module 1 has only one function. So I'll put the repeat x here, and it will take the two argument x comma n. So here I will take the 10 comma 3, 1000. That is the idea. Okay, now this is the first one. Now, so you see here we have implemented the module, we have put the one function using the module, and now we have incorporated the module from the command prompt. Okay, now we will do the next thing. We have the already implemented module. Now we will implement another program. From that program we will call the module. Okay, the same module. So this is the test underscore module underscore py. So you see here we have taken here, imported the module 1 first. Next we have taken the two value from the user as a user input, enter the number, enter the power, and then we have called the, if you write here similarly, you'll see the similar thing, module 1 dot, sorry, this thing. Yeah, repeat x. So what I will do here, v comma p. Okay, and now I'll write, enter the number, say 15. This is 4. So this is the way to incorporate the module and utilize the function which are available in the module to our program. Okay. Now we will implement the more complicated module. Okay. So here we have the two function on the Fibonacci 1 and Fibonacci 2, Fibonacci and Fibonacci 2. So similarly, if we again call and we have saved as a dot So fibo.py module name. Okay, so here we have the two function, fib and fib2. Okay, so if I use here import fibo, then fibo dot fib, then implementation is defined. Otherwise, both the function, the utility of both the function is same, logic is same, the display is different. Okay. That is the idea. So here you see, previously in our module, we have the only one single function in the module. But here we have the two functions in the module, and finally save the module with a fibo.py. Okay. So when you are utilizing the module, you have the two things. One is properly name the module with the .py extension, and when you are utilizing, when you are calling it from your program, that should be properly connected. That means the fibo dot, if you don't put the proper function name, so whenever you are writing the proper, your import operation is properly done, then automatically whenever you will put the module name and then put the dot, immediately will get the related function from the module. Okay. And secondly, so next we will do the one module. That module will contain the 4 defined arithmetical operation to perform the 4 defined arithmetical operation. Okay, so that is the idea. So we will prepare our own module, and then we will call the module to utilize the defined not the inbuilt, in the sense those function will be implemented by us. Okay, those function will be implemented by us. Okay, so you see, in the particular module, you see here we have taken the 4 function, and all the 4 function has a 2 input, A and B, and you see we have performed the defined arithmetic operation C equal to A plus B, then we have printed the C. Similarly, we have multiplied the C equal to A plus A into B, subtraction operation A minus B, and division operation A divided by B. Okay, so and these functions are saved in the, you see here, that is the AR.py extension. Okay, so once you have prepared all the function definition, completed all the function definition, and you have saved with a .py extension with a proper module name, your module is ready to use. Now you just test it whether your module is working or not. So what you can do, import AR. So it is successfully imported. Okay, no problem. Now, what you can do? Now you check AR dot. You see all the function names has appeared here. Add, division, multiplication, subtraction. Okay. Now, what we can do? Let's see. So here, so you see here. So here imported the AR module. Now, what you will do? We have taken the first number, and similarly, we'll take the second number. And now it is N1 and this is N2. N1 and N2. Similarly, AR dot subtraction N1 comma N2 AR dot comma N2 AR dot diff N1 comma N2. So this is the idea. So if we again run it second, sorry. What is the advantage of module? You see, suppose you have you are implementing one project. In the project, you have to use a defined type of function. Okay, and for example, suppose you are implementing some machine learning algorithms. Okay, now machine learning algorithms. So we have the defined kind of machine learning algorithm like supervised learning, unsupervised learning, regression analysis. So what you can do, you can prepare one supervised learning module, and under the supervised learning module you can keep the defined kind of classifier like the SVM classifier, K neighborhood classifier, multi-level perceptron, then random forest. So all the related classifier you can put in the classifier module. Similarly, when you are implementing the different clustering algorithms, you can put the different clustering algorithms in a one module. That is the advantage. So reusability. So reusability is one of the important factor of the object-oriented programming concept. Reusability, and it has also very much importance in context of the software engineering. Whenever you can able to reutilize the code, a piece of code, that will be extremely beneficial. Okay, when you are developing a large software. Now, So these are the different kind of modules that we have implemented using our own function. So there are lots of the inbuilt modules are also available. So let's check the one module first. So get pass is the module. It is something that's like the command prompt. It will prompt it will ask the password to give the password. Okay. So this is the inbuilt module. So if we run it, so I have not implemented anywhere the get pass module. It is already implemented. That's why I am just incorporating the get pass module through import get pass command. Okay. Now we have taken, so when get pass, it will prompt it to the user and it will take the password, and I will match whether the password is exactly equal to the Saurabh or not. Okay. If it is, then we can allow to enter in the module. That means we can execute some code, you can open some new window, whatever you want to do, or you will get the error message. That is the objective. So here, suppose I will turn immediately the wrong password, but even we repeat. So not this one. Now we'll show the another module, that is the calendar. It is very interesting and very effective for the different purpose. So suppose this is the calendar module. Now I want to display particular month, calendar dot month. So you see here, if I put calendar, okay. Let's try with the one program for I, say B equal to Let's try it whether it's running or not. Oh yeah. Okay, so we're getting all the calendar. Right? Why you are getting the November up to November? So next I will take the another example, that is the time. It is very much effective. So import time. Okay. So we have called the time variable, time module, incorporate a time module. So present time, date, and the month all are incorporated in the output. So this is the idea of the module. Okay. Now I will give you 3 small assignment. Okay, regarding the module at present. So before that, if you have any question, you please ask me.
So why we get up to November?
Yeah, you check the code first. I am just opening the code. You check it.
Because sir, range end value is excluded.
0 to
1 to 12. 13 लेंगे दिसंबर तक भी आएगा.
Understood. So I think this is the most confusing thing when you are writing the for loop in the Python, because when you are writing the for loop in the C language, you have to keep remember regarding the 0 and semicolon, and in contrast in the Python you have to always keep the range, because if you don't put the proper range, then you will not get the final limit. Okay, so that is the idea. Now either you can practice it, or I can give you some small assignment based on this defined module. Okay, so before that, if you have any question, or we can discuss the previous day assignment also. So if you have any doubt. Rahul, have you told anything regarding the previous day assignment?
Yes, sir. I send in the group.
Okay.
And also paste in the chat.
Okay. So have you got the what was the first assignment in the previous day? What was the
problem, sir?
knapsack problem? I think knapsack problem. All of you know the knapsack problem.
Yes, sir.
Okay. And regarding the traveling salesman and Chinese postman problem, you have any doubt?
Sir, Chinese postman problem.
Chinese postman doubts. Yes.
Okay. And the traveling salesman problem?
স্যার ওটা জানি
জানো তো, ঠিক আছে। ট্রাভেলিং সেলসম্যান প্রবলেম ইমপ্লিমেন্ট করতে পেরেছো?
স্যার নেট থেকে দেখে দেখে যতটুকু
Sir, we have to compare their graphs. What that it means, sir?
স্যার ওটাও একবার বুঝিয়ে দেবেন।
ঠিক আছে, সেটা বুঝিয়ে দিচ্ছি তাহলে। দেখো, সেটা বুঝিয়ে দিচ্ছি। একটু 5 মিনিট ওয়েট করো, আমি এটা নিয়ে আসি, আমি বুঝিয়ে দিচ্ছি একবার। আমি ওটা কানেক্ট করে
Okay, sir.
একটু ওয়েট করো। Okay, so first we'll discuss the traveling salesman problem. Okay, so in the traveling salesman problem, we have the, if you have the idea about the graph theory, so in the tiny salesman and the traveling salesman problem, we have the graph. Okay, graph means we have the defined kind of city. So this is A, B, C, D, like that. Now this is 1, this is 2, this is 3, 4, and 5. Now each city is connected. It may be within this. Cost is, say, for example, cost is 1, 2, 3, 4, 5, 6, and yeah. Now, as per the concept of traveling salesman problem, if salesman has started to visit city one by one, the condition is he has to visit all the city. He has to visit all the city only one time, and he will come back to the starting city. That is the first condition. Second condition, the cost of the total tour will be minimized. Okay, cost of the total tour will be minimized. The first condition, he has to visit every city by only one time, and total cost to visit the city will be minimized. That is the two constant. Okay, now this problem, the traveling salesman problem, is a classical computer science problem. Why? This is because the nature of the problem. If you want to start suppose you have the fourth city, then how many possible combinations are there? If you have the fourth city, then what will be the total combination?
To the power 4.
Okay. Now, the thing is, when your number of city is very small, then you can easily solve the problem using brute force approach. But whenever your number of city is very large, then it will come into the exponential figure immediately with a small increase of the number of city, and that will produce a huge search space tree, SST, or search space. And to explore those huge search space is very difficult to solve the problem. That's why we have the better solution to choose. Better approach we have to choose to get the solution. Now, this problem is not that we have mainly come in the computer science. We deal with the two kind of problem. One is the decision making problem, another one is the optimization problem. So decision making problem is you will get the yes or no outcome, 0 or 1, true or false, this kind of outcome. But suppose you are searching in a graph whether the graph has a cycle or not. So this is a decision making problem, not the optimization problem. But if you want to search the cycle with a minimum cost, that will come to the optimization problem. But before come to the optimization problem, you have to first find out whether the cycle is present or not. in case of spanning tree, minimum cost spanning tree, MST, because when your graph is given to you, you have generated a huge number of graph in spanning tree logically, but our intention is to find out the minimum cost spanning tree. Why? Because as per the applicability of the spanning tree, because we can, what is the utility of spanning tree? The idea of the spanning tree, all the vertices will be connected, right? Will finally, what if one graph is given to you, and we'll generate one tree from the graph, and that in that tree we have all the vertices we have in the tree, and obviously the edge set of the tree, spanning tree, will be subset of the edge set of the graph, original graph, but the vertex set will be exactly equal. So that is the idea. Now, so when we come to the minimum, then it will come to the optimization problem. Okay, and whenever the optimization problem is coming to the picture, we can use the greedy approach. Because why we are using the greedy approach? Because the greedy approach can give you the optimum result with a certain probability. Because it will not give you the guarantee that greedy approach will always give you the global optimum result, but it can give you the near optimal solution. Not the exact solution, not the exact optimal solution, but it is very close to the optimal solution, and that can be acceptable. Okay. So what will be the solving procedure? That is the idea first. The problem is clear. If graph is given to you, the city is given to you in terms of graph. So all the city are connected to each other. If it is a complete graph, then obviously it will be all the city will connect to each other. If it is an incomplete graph, then some of the city will connect it to each other. Now you have to find out a path, shortest path, by which the salesman will visit all the city only one time, and he will return back to the starting city with the minimum cost. That is very important, with the minimum cost. So if it is not the minimum cost, then it is not a solution of TSP. Okay. So minimum, when minimum is used, what is used, or maximum, it will definitely maximize the optimization problem. And since it is an optimization problem, so you can use the greedy approach to get the good solution. Next, so what is the approach to solve the solution? Suppose we have the graph. We have a graph. See H1. This is the city, okay? H2. H3. H4. H5. H6. H7. H8. Now these graphs are connected to each other, so we will draw the edge. This is 4, H1 to H6, then H1 to H5, which is the undirected graph. Okay, this is the undirected graph. So you see there is no direction of the edge. H2 to H3, that is 2. H2 to H4. This is 4. This is 1. This is H4 to H7. Sorry, this is not this one. H2 to H5. This is 3. H4 to H5. This is 7. Four. Two. 3. H1 to H6. 6. Now this is 7. So this graph, so this city and that cost is given to us. Okay. Now, what will be the starting point to solve the problem? Suppose okay.
Sir, can you maximize the step?
Sure.
Okay.
Better, na? Yeah. Better. Is clear, na? Hello?
Yes, sir. Yes.
Okay. Okay. So here we can draw one cost matrix. What is the cost matrix? So here we have the H1, H2, H3, H4, H5, H6, H7, H8. Similarly, we have the H1, H2, H3, H4, H5, H6, H8. Now you see H1 to H1, that means H2 to H2. That is a self loop. Am I right?
Yes, sir.
Okay, this is self loop. So here you see there is no self loop. We'll just either put the 0 value or you can put the negative value, or you can just put the some cross, whatever you do, you can do like that, or you can infinity, or it will be better if you put with a large value. That will be better.
0.
So diagonal is filled with some large value. Okay, fine. Now H1 to H6, we have path H1 to H6. Yes, we have path H1 to H2. First we start with the H1 to H2. Okay, do you have any path from H1 to H2?
Yes, sir. 5, sir. Cost.
Yes, sir.
Yeah, so it is 5. Similarly, since it is an unreacted graph, H2 to H1 is also 5. Am I right or wrong?
Yes,
Next,
sir.
H1 to H3,
No path, sir.
no path. So we just keep it blank, or you can, when you will implement in the program, you can put the 0 here also, no problem. So but here I'm just putting the dash here. H1 to H4, yes, we have. So it will be 6. Next, H1, so similarly H1 to H6, H4, 6. So H4 to H1, this is 6 also. Then H1 to H5, no. No. Then H6, yes, we
Yes,
have
sir.
4. H7, no. Here H, yes, we have. That is a 7. Similarly, H6 here, 4. H7, no. It is 7. Similarly, we start with the H5, H2. H2 to H1 already done. H2 to H2 not possible. H2 to H3. H2 to H3 it is 2. H2 to H3 it is 2. H2 to H4, 4. H2 to H5, 3.
3, 3.
3. H2 to H6, no. H2 H7, no.
No.
H2 8, no. So here we just write here similarly 2, 4, 3 and dash dash dash. Now H3. So H3 to H1, H2 already done. H3, H3 not possible. H3 to H4. It is 1. It is 1. Next one H3 to H4 already done. H3 to H5. No. H6? No. H7? No. H8? No. H4. Now H4 to H5. Previous one is already done. So H4 to H5. H4 to H5. Yes, we have 7. H4 to H6. No. 7. No. 8. No. H5 to H6. H5 to H6. No. H6 to H7. H5 to H7. H8. This is 4. So here 6 and 4. Right. H6 to H7. H6 to H7. Yes, this is 3. H6 to H8. No. So this is 3. No. So and finally H7 to H8. H7 to H8. H7 to H8. It is 2. And this is 2. Okay. Now you start to visit from H1. So our cost matrix is ready. So whenever you will going to solve the traveling salesman problem, you have to prepare the cost matrix, right? And once your cost matrix is given to you, then you will get the idea regarding the connectivity of the defined city. Okay. Now you start from the H1. Okay. You see here, we are adopting the Google, the greedy search approach, the greedy approach. So when we are searching using the greedy approach, we will always consider the local optimality. Local optimality in the sense, suppose you are in the city 1 and you are going to visit some other city. So you will first find out which city are directly connected with your present city. Say you are starting from the H1. Okay, say H1. So H1, your city H1 is visited it will be better to start here. Okay. So you start here. So your starting point is H1. So H1 you see H1 is connected with which city is connected with the H1 is connected with the how many city?
4 cities.
So H2, H4, H6 and H7, right? So you have the 4 options to choose. First, go to the next step from the H1. But what will be your logic to select a particular city? You are using the greedy approach. So you will always focus on the local optimum value. So here is the local, what is the local optimum value? We have the cost 5, 6, 4 and 7. So which one is the minimum one? 4 is the minimum one. Because our objective is to minimize the cost. Okay, our objective is to minimize the cost. So 4 here. So immediately I will visit the H1 to H6 with the cost 4. So we pay the cost 4. So I will add the total cost. So if I calculate here, the total cost equal to 4 plus something. Now we'll select H6. Now we come to H6. H6, which one connected to the H6? So H6, 4 and 3. H1 and H7. H1 and H7. Right? So we are here now. So if I now we are visiting here. Okay. So here we are here now. So when we are at the H6, we have the 2 options, H1 and H7. But you see, among the H7 and H1 we have already visited. Am I right? So there is no question about the revisit it again, because we have not visited all the cities till now. We have just started here. So immediately that will be removed. We will not consider this one. So by default H7 is selected. So now it will be H7. So we are now here, H7. Now H7, who are connected to H7? 632, right? That is the H5, H8 and the H6. Now same logic will be applicable for the H6. We will not consider H6 already visited. So now competition will be done on the H5 and H8. So which one will be selected? Since the H7 to H8, the cost is 2. So 2 is less than the H6, right? So H7 to H will be selected. Now H8, we have the 7. Now see H8, 7, 4 and 2. 7, 4 and 2. 2 will not consider now, so 4 and 7 now come to H5. So it will be come to H5 here. So H5, and what will be the cost? H5, it will be 4 and it will be 4. Now H5, who are connected with the H5? You see, who are connected with the H5?
H2 and H4.
H2, H4, H7 and H7 and H8. Okay. So H8 already visited. Just 1 minute. Okay. I'm just coming back. Hello. So we are in the H5, right? Now, can you hear me? Hello?
Yes, sir.
Yes,
Okay.
sir.
So we are in the H5. So in the H5, we are connected with the H2, that is 3, H4, that is 7, next H7, that is 6, and H8, that is 4. Now you see who are already visited. H2, it is not visited till now. H2 is visited? No, it is not visited. H4, it is already visited. No, it is not visited till now. H7, it is visited, and H8, it is visited. So 3 and 4, we will consider H2. So we will move from here. So from here to here. So it will be H2, the cost is 3, and here the cost is 3 plus H2. Now H2, come back to H2. H2 is connected to H1 with 5, H5 with 3, H4 with 2, and H2, H3. So 5, 2, 4, 3. So which one is the minimum one? H3. Is it visited already? No, it is not visited till now. So it will be 2. Now H3. H3, H3 to H4, it is visited. So H3, we can move H2 or H4. Either you can move H2 or H4. So H2 is already visited. So you move here. Sorry, not here. H3, then H4. One. And finally H4 to H1. So it will come back to it again. So that is the method to solve your TSP problem using greedy algorithm. Why it is greedy? Because you see each and every step. When we are moving to the next step, we are considering only which one is locally minimum. Which one is locally minimum every time. But you remember always, the greedy approach cannot give you the guarantee that it will finally produce the global optimum result, but it will produce the near optimum result. Because since we are extremely believing on the local optimum, so it is a good chance to start into the local optimum. Okay, that is the limitation of the greedy approach. So when you are implementing using the Python, what you can do, you can use you can implement your graph using the defined dictionary or list, whatever maybe you can use, and you just consider then you implement a simple function. Okay, but remember one thing: if there is no cycle is present in the graph, then you cannot solve the traveling salesman problem, because it is not possible always that every graph has some solution of the traveling salesman. It is not possible. What is the application of traveling salesman problem? It has a lot of real life application, like air traffic control or air traffic route planning. Okay, the optimum floor planning in the, since it is a combinatorial optimization problem. So whenever any kind of combinatorial optimization problem, if we bring into the under the traveling salesman problem, map with the traveling salesman problem, you can easily solve it. Okay, and why it is important? Because it's complexity. Because till now, no polynomial time complexity algorithm has been discovered. No polynomial time, not discovered. Okay, so when you will increase the number of city, immediately it will take the exponential time. That's why we are so much, the computer science people are so much interested in that kind of the problem. Okay, so that is the idea. So the graph is given to you. You have to visit every city only one time and come back to the own starting city, and the total cost of the city will be minimized. Visiting city will be minimized. That is the definition of the problem. Okay, and this is the basically it is a combinatorial optimization problem. Why combinatorial optimization? Actually, the how you are visiting the city, because it is solution is totally the order of the visiting city, right? So here what is the order? H1, H6, H7, H8, H5, H2, H3, H4, and come back to the H1. That is the order, right? So someone should visit the city like that: H1, H7, then H6, then H8. It may be possible, but that will not give you the exact answer. So in the literature, there are lots of different kind of with an n number of city, n value of n equal to 4, 20, 30 are available to test whether you are getting the exact solution or not. Those are real life of TSP problem. Okay, so you can in your project, in your Python class project, even you can implement a simple TSP problem, and you can evaluate the performance under the different number of city and analyze the performance. Okay, no problem. And next discussion, if you implement this one, next discussion I will discuss. I will discuss the. I will share the Chinese salesman problem, Chinese postman problem. The almost is quite similar to each other, but slightly different. We will impose one restriction and we will lose the another restriction in the Chinese postman problem. Okay. So next 30 minutes, you will implement some module program. Okay. So either I can give you the some assignment, or you can practice by yourself, whatever you want to do. I will give you the assignment.
স্যার অ্যাসাইনমেন্ট দিয়ে দিন।
ঠিক আছে। আর এটা ট্রাভেলিং সেলসম্যান প্রবলেম বুঝতে কোনো প্রবলেম হয়েছে কিছু?
না স্যার।
ওকে, ঠিক আছে। আর এটা ইমপ্লিমেন্ট করলে নেক্সট ডে আমি এই তোমার ট্রাভেলিং সেলসম্যান নেক্সট চাইনিজ প্রবলেমটা করে দেবো, চাইনিজ পোস্টম্যান।
আচ্ছা স্যার, ঠিক আছে।
তাহলে 5 মিনিট ওয়েট করে আমি অ্যাসাইনমেন্টটা দিচ্ছি। You check the chat box, okay? Develop Python module which includes the following function: variance, standard deviation, skewness, and kurtosis. The function will work on multi-dimensional dataset. You will generate the dataset randomly within user-defined range. Okay. So what you have to do, you will generate one dataset. That will be the range of the dataset will be given by the user. So you have to use the rand function within a given range. And initially you implement for the one-dimensional array. That means, suppose your array is containing the 550 elements. Now you calculate your function will calculate the variance, standard deviation, skewness of the dataset, and the kurtosis. So those four are the defined statistical measurement on dataset. So if you go for any kind of machine learning, if you want to calculate any kind of feature, statistical feature, these four are the very common statistical feature that can be used for the feature extraction. And these are called the color momentum. Color momentum when you are extracting those four features from the color images. These are called the color momentum. So you can get some information features if you extract so I am not going to the details of the color momentum, but this is exactly when you will extract the variance, standard deviation, skewness, and kurtosis from the color image. These are called the color momentum. But here you will concentrate on the first 1D image, 1D array, 1D dataset. That means your array will contain only one-dimensional value, 1 cos 10 or 1 cos 50. Next step, you move to the 3 cos 3, and next you move 4 cos 4 or 4 cos 5 cos 6, like that. When your data is multi-dimensional, you try to convert it into single dimensional. Okay. Have you got the idea? Initially, you start with the one-dimensional data. Generate the data randomly in a 1D array, and you calculate all these four. And where you can get the formula, you search in the internet, you will get the formula. No problem. These are common formulas: standard deviation, variance, common formula, skewness. The assignment is clear? Hello? Hello?
Yes, sir.
Okay. So you will develop each and every function and put in a one module, say statistical feature. You can put the name statistical feature, name of the module, and on the main function, you will generate the data and pass the data on those functions. Just whatever I have shown in the discussion in that way. Okay, so do it. It will take not very long amount of time. You just try it for the one-dimensional, and later time you go with the multi-dimensional. In the lab, you just try with the one-dimensional.